So, good morning, students. I welcome you in the lecture of microengineering. So, we are discussing about the microtubes. We are discussing about the microtube. In the previous lecture, we have discussed how microtubes work, and we have started with the one of the tube. So, in this lecture, we will continue the same series of microtubes. So, if you are not subscribed my channel, please click on the subscription button, and if you are subscribing, you are getting the latest update of each and every video which I have uploaded on my YouTube channel on regular basis. And you can browse through the playlist and you can watch the videos of electronic devices circuit as well as microengineering as well as discrete time signal processing. So I will start the lecture. So we discuss these things. That is nothing but the microtube. There are two tubes. That is nothing but the linear beam and nothing but the cross-field tube, cross-field devices. In the linear is nothing but you will find a linear electron beam over there. And in the cross-field, you are not finding electrons are moving in the straight direction. They are moving like this one in the circular pattern, in the clockwise and anti-clockwise pattern. So there are two types of crossfield. That is nothing but the magnetron, which you are using in your micro ovens, and there is nothing but the crossfield amplifier (EFS). Then in the linear beam, there are two cavities. That is nothing but the resonant cavity and slow wave structure. That is nothing but the non-resonant. So in the resonant cavity, you will find the two amplifier. That is nothing but the klystron amplifier. First is nothing but, and second is nothing but reflex klystron. In the slow wave structure, you will find a forward wave, that is nothing but helix traveling wave tube and coupled cavity traveling wave tube. And in the backward wave, in the slow wave structure, you will find a backward wave amplifier and backward wave oscillators. Okay, so these devices we have to study as far as this exam is concerned. These are very very important topics. Very very important. Which are important? You will find a 10 mark question on this, then 10 mark question on this one compulsory. Then magnetron they will ask one. Then helix. Every topic is essential in this case. So I think we have started with this. So how velocity modulation takes place, what we are doing in the velocity modulation, that I will explain in short to you. So what we are doing, there are three electrons. That is nothing but the one electron we what you can say, which is having higher velocity. Higher velocity. Suppose one electron number one is having higher velocity. So what we are doing, we are de-accelerating that electron. How we are de-accelerating the electron? By applying polarity like this one. So what will happen? This minus sign and electron is having the negative potential. So what will happen? They are getting retarded. So the electron will get de-accelerated. Second electron, which we are not doing anything. So we are replacing the polarity of the buncher cavity over there. So what will happen? The electron velocity is unchanged over there. And in the third case, what we are doing, we are changing the polarity. By changing the polarity like this one, so third electron which is having less velocity, so we are increasing its velocity, so electron will be accelerated. And these electrons, why we are doing this thing? Why we are doing? Because what we have to do, we have to make the electron at the bunches. We have to bunches the electron. So whatever the highly accelerated electron that are de-accelerated, the electron which we required, we are not doing anything with that. And what we are doing, we are accelerating the electron which is having low acceleration. So they are forming the bunches, and from these bunches we are taking out the energy, and that energy we are giving to the whatever the signals to micro frequencies. This is the difference in between this one. So this is happening in this case. So these are nothing but the grids. You will find a grid over here. Will grid over there. In the grid, we are giving the what you can say polarity over there. And these are the cavities. This is nothing but the bunching cavity, and this is nothing but the catcher cavity, where we are catching the electron, not exactly catching the electron, but we are taking out the energy from this one. And the space in between these two is called as drip space over there. And here you will find the bunching of electron. Here you will find the bunching of electron, and here also you will find the bunching of electron. Okay, so this thing we will discuss today, how we are two cavity and a klystron amplifier we will see today. Okay, okay. These two things we have. So two cavity klystron amplifier. So how it works? How it works? So there are two cavities. Nothing but the puncture cavity, and the second cavity is nothing but the catcher cavity. Here in the diagram you will see this is nothing but my puncture cavity, and this is nothing but my catcher cavity. So as far as the klystron is concerned, there are two types again. One is amplifier, and second is nothing but the oscillator. So klystron amplifier is having two cavity or multi cavities. One cavity is called as what? Buncher cavity. We are giving the input. As far as amplifier is concerned, we know that amplifier require any input. Okay, we require any input. And for oscillators, this is the oscillator structure. Okay, this is the reflection oscillator. So here you don't require any kind of input. So the buncher cavity, we are giving the micro signal over there. The AC signal is given through this cavity, and this electrode you will find over there, that is nothing but the accelerating grid. Wherever there is electron that is generated by this cathode grid that is accelerated by this anode. So we know that electron is having negative potential over there, negative polarity over there, and which is accelerated by this anode. This anode will visible over there, that is anode. So the accelerated electron is get bunched by this buncher cavity. The bunching of electron is carried out by buncher cavity over there, and the electron you will find like this one. The structure of electron is like this one. Like this one, the electron is amplified. Okay. So density of electron you will find over there. That is nothing but the you will find the more dense electron over there. Sorry. So the space in between the catcher cavity and the buncher cavity, we know that that is nothing but the drift space over there. And in the buncher cavity, we are bunching the electron. So this is nothing but the electron beam. This yellow color. So not yellow color. Just I will rub the portion first, and we will clearly visible this portion. Okay. So electron beam. This is the electron beam. Okay. This is the electron beam. This is the electron beam. This is the electron beam, and the collector electron beam is catch over. Okay. So this collector is having the positive potential over there. Positive potential. That's why electron is moving like this one. Okay. This is a very small device. Okay, but as far as this construction is there, we have mentioned like this one. So whatever the electrons are there, they are bunching over there, and in the catcher cavity, we are taking the energy from that one, and the output is carried out over here. So how we are getting the energy from this one? So we know that electrons are moving faster over there. The electrons are moving faster over there, and the signal, whatever signal which we want to amplify, that is given from this space. This space. So the electron bunching is carried out over there. Bunching is carried out at these places. So that will give the energy to that, and the signal will get amplified. We know that in the amplification process, we are increasing its amplitude. We are increasing its amplitude, so the frequency remains same. The frequency remains same. Frequency remains same. So here, due to the accelerating of electron and the bunching of electron, we are getting the maximum amplitude over there. Maximum amplitude over there, and in the micro output, we are getting the output over there. So this is the simplest working of this two-wave klystron amplifier. So again, this structure is like this one. The cathode, you will find the cathode over there, which will generate an electron beam. So this color indicate the electron beam over there. This is the electron beam, and here this is nothing but my RF input signal. Here is nothing but my RF signal. Here I am extracting my output over there. Then you will find a space in between these two is called as my drift space over there. Okay, and the potentially the polarity is given like this one. The cathode is giving the potential as negative, and the collector is having potential as polarity as positive over there. Okay. So in this way, you will find there is a bunching of electron over there, bunching of electron over, bunching of electron here, and RF output is carried out over there. RF output is carried out there. Like this one, I will explain. I will explain this. The dotted line over there is dotted line is nothing but the bunching of electrons. So bunching will give you the maximum energy to my input signal. Maximum energy to my input signal. So here input loop is there, we are giving the input from this end, and we are extracting output from this end, and the direction of electron is like this one. Okay. So what you have to remember, this is the bunching cavity where we are providing input, and this is the catcher cavity we are taking the output from this one, and this is the collector one. Okay. So this is the again two cavity klystron amplifier. You will find the same thing we have discussed. This is the multi cavity klystron amplifier. So what exactly mean by multi cavity? We are giving the multiple inputs. We are giving the multiple input here. Just a minute. Okay. Here we are giving input. Here we are giving input, and output we are taking across this system. The remaining working is the same one. So this is nothing but a reflex klystron over there. Okay, reflex klystron over there. So what exactly mean by reflex klystron? That we will see. Uh, so in the reflex klystron, what exactly mean by reflex klystron amplifier? This is nothing but oscillator. So we know that the difference between oscillator and amplifier is that we are not giving any kind of input. We are not giving any kind of input to the oscillator. The signal micro frequencies are generated from this micro oscillator. So how we are generating? So here you will find there are resonating cavities. These are the resonating cavities. So cathode, here you will find a cathode which is generating the what? Electron. So as far as the electrons are concerned, there are first electron, second electron, and third electron. There are the cases of electrons. So how these are cases? The first electron which is having, what you can say, which is having more less what you can say, acceleration. So more acceleration. So what will happen? This repeller is having positive potential over there. Positive potential I have given over, sorry, negative potential over, sorry. Negative potential over there, and the potential is we are varying from this knob. So the repeller is having negative potential. So we know that negative, negative will repel the electron, but the electron is having higher acceleration. So what you do, it will go like this one. But here, due to the negative field, what will the electron will go like this. So the moderate electron will exactly follow the same path, and the electron which is less accelerated, it will go like this one. So at this place, we are bunching again. We are forming the bunches in electron at the same point. At the same point, due to that bunching, we are in the resonant cavity. We are getting the resonance, and resonance will form what? It will form oscillations. It will form an oscillation. In the resonating cavity, we are giving the positive potential over there. So this is the simplest working of any reflex electron over there. So what will happen in this case? So suppose this is nothing but the electron 1, 2, 3, 4, like this many electrons are there. So this electron, this is the repeller space, okay, repeller space over there. So what will happen? The electron is going like this one, and is it deaccelerated by the repeller space, and that is bunch at this point over there. Again, this same electron, this third electron, this fourth electron, and this fifth electron. This fifth electron, they are bunching at this place, and due to that, what will happen? Due to that, what will happen? That are forming the bunches, and we are getting the oscillation at the resonant cavity over there. This is the simplest working of the reflex crystal. So I think we have to stop over there. In the upcoming lecture, we will see the traveling wave tube, TWT, then how velocity modulation occurs in there to TWT, then BWA, and we have to see the application of this device. So after that, this module is, I will declare that this module is over. So I think I have to stop over there. So thank you very much. If you are having any doubt, you can mention in the comment box. Thank you very much.